This is the notes for Algebra 2, graphing polynomials. Okay, the first thing that we're going to be talking about here is end behavior. I know we talked about this a little bit on the last class period, but we just want to make sure that this does hit home. And so just remember, if that degree of your polynomial is even and that leading coefficient is positive, all right, we are going to be having an up motion here, okay, on that graph as we see that. When we talk about the end behavior, it is as x, okay, approaches that positive infinity, the function is also going to be going to positive infinity. So as we see that, it's going this way, it's going up. As it's going to the left, it's also going up. We call these ups. This could be an x squared. It could be x to the fourth. Same thing if it's negative. Okay, guys, if this is positive, it doesn't matter. My end results, as both of them are negative. Okay. When we come down here, we said if I had an odd degree, my leading coefficient is positive. I'm going to start low, end high. So it's going to rise right, fall left. Okay. From that center point here. Okay, that point of inflection. And so same here, if it's an odd and it's negative, I'm going to be falling going left to right. Okay, and then, falling on the right and then rising on the left. Okay, so that kind of talks about the end behavior. Next thing we want to talk about is the turning points. Okay, so if it has a degree of n, the maximum number of turning points is n minus 1. So for example, okay, if my graph is y equals x to the fourth, okay, my max turning points would be 4 minus 1. So the max I could have is 3. Okay, we come down here and we look at our roots. All right, if it has an odd multiplicity, meaning that the power of that root is only 1, it's going to be a through. Okay, see where it crosses the x-axis. Okay, and then if it's an even, so maybe it looks something like this, x plus 2 squared. So that means that that is a 2, so it's going to have multiple. It's going to bounce. All right, so it has that U-turn. It's going to bounce there on the x-axis. It's not going to go through it. Okay, so let's look a little bit about end behavior and talk about those, shall we? Okay, so the first one we have is negative 5. Let's see if we can't just zoom into that a little bit better. Okay. Okay, so the first thing that we have is negative 5x cubed. We see here the degree is a 3. Okay, the sign of the coefficient is negative. All right, and so as it goes to the left, it's going to rise, and it's going to fall as it goes to the right. Okay, so it will look just like that. It's a flipped. Okay, all right, the same thing applies here. Negative x cubed plus 1. We see here the degree is 3. That leading coefficient is negative. And so again, we're going to rise towards infinity and go up, and we're going to fall as we're going right. Okay? Now, again here, we look here. Here's a 4. All right? And then we see that I have a negative leading coefficient. So that means that they're both going to fall. Fall, fall. Okay? All right, the next one here, we come here, my highest degree is 3. The coefficient on that is negative. Okay, so again, I've got a rise and a fall, so it's going to rise and fall. Again, the way that looks is just like that. Okay? Then we get down here, hey, I've got a 4 again, but now we see that it's a positive front, so I'm going to have rise, rise. I know this is a lot of examples, but I really want it to hit home. Again, x to the fourth here, degree is 4. It's positive, so it's rise, rise, okay? My graph's going to have that U in it. Come here again, leading coefficient is a 4. Out front is positive. So rise, rise. Okay? And then this last one here, my degree is 4. It's positive out front. And again, since it's an even number, my ending behavior is going to be the same on each side, and I'm going to rise and rise. Okay? Now we come down here, and just to be very clear, my degree is 5. It's a negative leading coefficient. Okay, so we know that it's an odd one, so they're going to be different. All right, if I look at my cheat sheet up here, I've got an odd and it's negative. I'm going to rise, left, okay, fall, right. Something along that nature. Now, if my degree is 6 and I have a positive leading coefficient, now I'm looking at an even and positive. So I come up here, even, positive. Okay, I'm going to rise, left, rise, right. It's going to look somewhat like a parabola, just like that. Okay, lastly, to hit this home, guys, we look at these. I see here my endings behaviors are different. So if they're different, they're pointing different ways. I know that this has to be odd. And since I'm finishing going up to the right, my tail is going up, it has to be a positive leading coefficient. I come here, both endpoints are pointing the same direction, so I know my degree has to be even. And since they're pointing up, my leading coefficient has to be positive. And then lastly here, I see my arrows pointing different directions, which means that it has to be odd. And since it's finishing pointing down, this is my negative guy. Okay? So that ends page 1. Let's go to page 2. Okay. There we go. Okay. So I have my polynomial here. I want to see what the leading coefficient is. All of these that you notice are in factored form. Okay, they're all in factored form. So I look here. My leading coefficient is out front. It's a 2. My degree is, I count my x's. Okay, now this x is squared, so there's 2. One more gives me 3. Now the numbers of zeros I have, though, is 2. The number of turns I have, okay, remember that's that at most n minus 1. This is a normal one here, so I'm going to have 2. Okay, and the actual zeros and their multiplicity. All right, so now again, remember we say that this is a 0, this is a 0. So I look here, x plus 2. So I know that a 0 is going to have to be negative 2, 0. We'll put it in ordered pair form. And then also 4, 0. Because 4 is going to have to be a 0. And we talk about this. Since there's 2 of them, we come back to this, okay? And that's where we talk about it has an even multiplicity. So that's going to be even. And the 4, 0 is going to be odd. Okay? So now I come to this next one. All right, my leading coefficient, there's a negative in front of this x, so it's a negative 1. My degree is 1, 2, 3. My numbers of zeros is 1, 2, 3. My number of turns, 3 minus 1, is 2. And we come over here, okay, guys? Hey, if I have an x by itself, that is 0, 0. X minus 7, we change that sign, and it becomes 7, 0. And then x plus 4 is going to be negative 4, 0. And since they're all singles, they are all odd. Alrighty, let's look at the next one. The next one, I have nothing out front. Okay, sorry about that. There we go. I have nothing out front. So that means that it is a 1. Alrighty. I look here, I do have x squared and one more x, so my degree would end up being 3 if we factored that out. Alright, and then the number of zeros I have is 3. Now the number of turns is actually going to be a 0 here, because as we look, guys, we set both of these to 0, and so what happens when I have x squared plus 1 equals 0? Well, the first thing you do is subtract 1, and I get x squared equals -1. We know that x squared, hey, when I do this, I'm going to get the square root of -1. The square root of -1 is an imaginary number. So it's actually, that's going to be a point that, a bounce that doesn't land on an x-axis. There's no 0 to it. Okay, so I won't even have it. And so what this is going to look like, guys, is it's positive. So my graph is going to look like this. Okay, and it's just going to have a point of inflection here. There's actually not going to be a turn. Okay, so that's why it is 0. Now when we do talk about the zeros, the actual zeros, we're still crossing at 1, 0. As if there's one of them, it is odd. Okay, let's come down to the next one. I've got x plus 3 squared, and x plus 1. All right, so I look here, my leading coefficient is 1 because there's no leading coefficient in front of the variable. I have 1, 2, 3, 4 x's because this is squared. I talk about my degree, and my degree is, I talk about the number of zeros I have. I have 1, 2, 3, then I'm going to solve for. The number of turns I have is 3, because it is a degree 4. And look here. X by itself is 0, 0. We know that. Now, x, let's skip this. We'll come back to it. X plus 1, so we know that x has to be -1, because -1 plus 1 is 0. And then let's go ahead and solve this. X plus 3, so that makes that a -3. Makes that a -3. And since there's 2 of them here, we know that that's going to bounce. It is even. Whereas these two here are both odd. All right. Let's look here, and this one is a funsy. First thing we know is I look at my leading coefficient. I have a negative out there, so it's -1. And then what we need to do, guys, is we need to actually factor these out. Okay, x squared minus 4, that's perfect square. Okay, so it'd be x plus 2, x minus 2. Same with this 9, x plus 3, when we factor it out, x minus 3. So that's what I have. My degree is 4 because I have 4 x's. My number of 0 is 4. And then when I look at my terms, n minus 1, 4 minus 1 is 3. So I look at my zeros here. Okay, guys, I'm going to have 2, 0, -2, 0, 3, 0, and -3, 0. Since they all are a degree of 1, these are all odd. Okay. All odd. And then let's look at the last one here. I look at my leading coefficient. That's a -1. I count my x's, 1, 2, 3, 4. How many numbers of zeros I have. Okay. I look here, guys, and I'm going to have 3. Okay. And then when I look at my turns, okay, I look at my terms, and I'm going to have really 1 because when we look at this, okay, guys, this 0 here, we know that that is 0, 0. I come over here, this is going to give me 2, 0. And then I'm going to have an imaginary 0 here because when I do that, remember x squared plus 3 equals 0. You move that over and it's x squared equals negative 3. Again, I'm dealing with an imaginary number. Okay? And so that's why that wouldn't be on there. It's imaginary. I'm not going to have a term there, though, but we do know it's a cubed root. It's to the 4th, so we have to have a term to make it come back down. So you're going to have 1 term there at least. All of these have a power of 1, so they will be odd. Okay, let's flip it over and go through a pretty nice long example for number 2. Okay, so we have, here's our huge polynomial. Huge polynomial. So we're going to talk about the end behavior. I look here, I see that my leading coefficient is negative. Okay, and then let's count our x's. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's going to be a negative even, which means that I'm going to fall right, fall left. It's going to look something like this. Okay, let's determine the zeros here. So I come through here, hey, this is going to give me a, all right, negative 1, 0 for this one. I come here, we change that sign, and that's going to give me a 2, 0. This is going to give me a 3, 0. And then again, here's this imaginary number, guys, where you're going to have something, you know, along the lines of a square root of 2i, 0, but I'm not going to give you anything like that really moving forward, just that's what it would look like. Determine the x-intercepts of those, guys, and I'm sorry, I wrote these, and I've been writing these this entire time, and I just realized this. My actual zeros, guys, we're going to make those. I wrote these as x-intercepts. When we talk about our x, so up here, you know, guys, we're going to list it as x equals negative 2 and 4, like that. So I apologize. I just now caught that. I'm sorry about that. So when I do these, guys, I really need to write x equals negative 1, 2, 3, and square root of 2i. And again, this one here, don't worry so much about that. I won't really grade you too heavy on those, just because we haven't talked about them that much. Well, we haven't talked about them at all yet. Okay, determine the x-intercept. So guys, that's what I wrote up there. That's what we have. That's going to be that negative 1, 0, 2, 0, 3, 0. And, you know, we'll have that negative number. I want to make sure that you know that our x-intercepts are here. Okay, to find the y-intercept, guys, we plug a 0 in for x. Because again, I'm looking at this graph over here, okay? We're crossing this y-axis somewhere. My x value is 0 on that. So that's why I'm plugging in a 0. So I say, okay, negative 2, maybe we'll be able to do it so that you can see it. So there's the negative 2. All right, and I come up here and I plug a 0 in there, so 0 plus 1 is 1. So 1 squared, 0 minus 2, so I got a negative 2. I got a 0 minus 3, so that's a negative 3 cubed. And then I have a 0 there, so that's just a 2. All right, so now I've got negative 2. 1 squared is 1. Negative 2. A negative 3 squared, so that's negative 3 times negative 3, which gives you a 9. And then another one's negative 27, and then a 2. We multiply across, negative and a negative give me a positive 4, negative 27, and 2. 4 times negative 27 is a negative 108. And we take that times 2, so you get negative 216. And guys, I want to put this as an x-intercept. Sorry, I didn't realize that was going off the page. We want to write that as, a y-intercept. Okay, so that would be, instead of like here with the x-intercepts, now we're plugging in the negative 216. Okay, that's what that's going to look like. Describe the behavior of the graph at each x-intercept. Okay, so we've got the negative 1, 0, the 2, 0, and the 3, 0. All right, now we look here, the negative 1, that was for, that was a squared. That x plus 2 is, x plus 1 was squared. So I had an even multiplicity. So we're going to say that this is a bounce. Okay, it's going to be a U shape on it like that. Remember, it bounces on the x-axis. It doesn't actually go through it. On the 2, 0, and the 3, 0, we look here, okay. On the 2, that's a single power. It's an odd. Come over here, 3 is odd. So they're both odds. So this would be a through on those. Okay. And then without using a calculator, sketch the function. So, okay, guys, I come here. I've got to sketch this. So put in what you know. Okay, we know that it's going to fall left and fall right. So I know I'm going to have my arrows here pointing down of some sort. Now I know my x-intercept, so I'm going to cross at negative 1. And actually, let's space this out a little bit. So there you go. Okay, we're crossing at negative 1, we're crossing at 2, and we're crossing at 3. All right, we know that it has to come down just like this. And we said here it bounces on the negative 1. So we know that this is a bounce right here. So we know that I'm going to be sketching somewhat like this nature. I'm going to bounce. We know that these two are throughs. So I'm coming like this. Okay. Just like that. Let's go ahead and connect that to the line there. So I have that. And this is my last thing, guys. And I see that I cross at negative 216. I'm going to be coming way down here, clear down to 216 before I get that graph. And then this is what my graph would look like, guys, somewhat in a nutshell. Okay, let's go on to the third and final page. Let's do the standard form first, and then we'll do the factored form. Okay, so I look here, guys, my degree, I look at the leading coefficient, it is a 3. My degree is, I look at the leading coefficient, it's a positive 2. Okay, I'm going to write here just so you know it is positive. And that means that my end behavior, guys, my end behavior with the degree of 3, they're not going to be the same, but I'm going to be falling left, rise right. In other words, it's going to look something just like that as far as my end behavior. Now let's talk about the zeros and the x-intercept. So I've got to do a couple things here. First off, I see a like term that I can pull out of those because we're going to have to factor this out. So then that means, guys, I can pull an x. So I'm going to have 2x squared plus 11x plus 15. And now, guys, we need to factor that. Okay, I'm going to come down here. We're going to do the AC method in factoring, and I'll use the box to show it happen. Remember, this is A and C. So I look here, 2 and 15. That gives me 30. I look at B. B's an 11. So I come here. Well, we know that things that multiply up to 30, they give me 11. 5 and 6. 5 times 6 is 30. When I add them together, I get 11. So, guys, you said you liked Mrs. Beamer's box. remember I come here, and what goes here is the a value, 2x squared. We put the c value down in the bottom right. And then we split this 5 and 6x up. So this is a 5x, this is a 6x. This kicks it off. The only thing they have in common is an x. What's left over? 2x. I divide 6x by 2x and I get a 3. I divide 15 by 3, I get a 5. Does this match? Yes. So that means coming up here, guys, I'm going to have x, and I'm going to have x plus 3, and I'm going to have 2x plus 5. Okay, technically that's f of x. So now I'm going to look for my x-intercepts, guys, and the zeros there. Okay, 0 is one of them, so it'd be 0, 0. This here we change the sign, and that's going to be a negative 3. Negative 3, 0. And then we look at this one, guys. I set that to 0. I move the 5 over, divide by 2. Okay, I'm going to have a negative 5 halves, 0, because the sign has changed. My multiplicity, I look up here, guys. All right, they're all odd. All odd, so all of them are all odd. So that means that they all three are through. Okay, the behaviors. Okay, guys, at negative 3, 0. Okay, I'm a through. At negative 5 halves, I'm a through. And at 0, 0, I'm a through. I look at my y-intercept. I plug a 0 in for all of these x's here that we have. I plug a 0 in for these. If I do, this cancels, this cancels, this cancels. I'm just left with 0 as my y-intercept, 0, 0. And then we're going to draw a graph, guys. So here's my graph that we know. See here, I know that my end behavior is going to point down on this side and we point up on this side. And then just count your zeros. We know that I'm going to be 1 at negative 3. 5 halves. A lot of us don't even know what that would be. That's a negative 2.5. Okay? So that means I'm going to be crossing just right here again. And then I'm crossing somewhere a 0. So that means I'm coming up. We know it's through because it's odd. I come down again, and then I'm going to come up and through. Now this here and this here might be off, but we just want to know, do we know that actual shape? Okay. Now I come here and my golly, this is a doozy. I got 1x. This gives me 2 x's, so now I'm up to 3. Since this is exponents and we're using parentheses, we're going to multiply. So I've got 3 already. I add 6 more to it. I got a 9 because 2 times 3 is 6, 7, 8, 9. My leading coefficient in front of all this is a negative 5. So we do know that it's negative. Okay, which means that my end behaviors are going to be different. So if it's negative, that means I'm going to rise left, and I'm going to fall right. Okay? So now I'm looking here. I'm going to look at zeros or my x-intercepts. I come up here, negative 5. That doesn't tell me when. I look here. This does, so I know I'm going to have negative 3, 0. Check. Come over here. I'm going to set this to 0 and solve. Or remember we said change the sign back over front. So I change the sign as positive 1 over 2. Okay. Then I come here. This is again is that whole x squared minus 4. Now that tells me, guys, that this is perfect square. It's not imaginary anymore. It's actually x plus 2 and x minus 2. Okay? And that actually will be all cubed and everything, just like that. So that means I have 2 more zeros, one at negative 2, 0, and another one at 2, 0. We talk about our multiplicity. Okay, we got our odds and our even. We look here, we've only got one even, and that's our 1/2. Okay, that's our 1/2. And then we look here, guys, odd, and then these are both odd as well. So we've got -3, 0, -2, 0, and 2, 0, and all of those are odd. Okay? We look at our behaviors. All right. So let's write these down again. -3, 0, -2, 0, 1/2, 0, and 2, 0. So guys, this is going to be a through singled. Okay, this is going to be a through as well. Now here, guys, we see that it's squared up top, so we're going to have a bounce. All right, and it's actually going to bounce up, and then at 2 we're going to fall, and it's also going to be through. It's going to go down. Alrighty. Okay, now I'm looking at my y-intercepts. We're just going to plug in a 0, guys. So I got -5. Okay, if x was 0, that makes this a 3. I plug in a 0 here, that makes this a -1, and it's squared. And I plug a 0 in here, and it's -4. And I'm going to cube it. So I come here, guys, this is going to give me -15. I square this, this is going to give me a 1. And then -4 times -4 is +16. Times 4 again, guys, is -64. Drop that 1, and now you're just left with -15 times -64. I'm not as good as I once was. I do need a calculator. 15 times 64 is a 960. And it is positive because of this. So the way we write that, remember, is 0, 960 because that's an intercept. And then the only thing left for us to do, sketch our graph. So I look here, guys, at my zeros. Okay, 1, 2, 3, 1, 2, 3. I cross at -3. From here, I cross at -2. I cross at 1/2, and I cross at 2. We know, guys, that I'm rising to the left. I'm falling to the right. Okay, through. This is going to be a bounce. So we do know I'm going to have a bounce action there. And now we just kind of trace it how we want. Now, the one thing we do know, guys, is that, look, that's a 960. There's no way that's going to be on my graph. That would go out of the graph, and then we come back down, okay? We do this, and there's my graph. So, okay, guys, that's it. That's it. That's in a nutshell. In behavior, finding the zeros and so forth, and the multiplicity of graphing these polynomials. So without that, I bid you adieu and good luck on your homework. Have a great day.